Hey everybody, today I'm just going to make a short video on a tuning system that is a bit of an underdog, quarter comma mean tone. It's a tuning that is designed to maximize your 5-limit thirds, sixths, and sevenths. And it does so by tempering its fifths from wolf fifths into little puppy fifths. So almost all the fifths are detuned by about 5.7 cents. And of course, the inversion of this will be a wide fourth. So why use these strange, slightly out of tune intervals? What's the purpose of this? Well, it's actually quite genius in how it solves a certain problem caused by the divergence between prime factors in the harmonic series. Basically, if we take a circle of pure fifths, Pythagorean fifths, and we keep going up, well, while these are all perfect intervals, it leaves us with a very sharp major third. Here they are compared back to back. So this difference between this 5-limit pure major third and this 3-limit Pythagorean major third of 81 over 64 is a very small interval of 81 over 80. So we can think of 80 over 64 as another way of representing 5 over 4, and then 81 over 64, and the difference between them is 81 over 80, known as the syntonic comma. And while this is a small, subtle difference, it does make a difference, and it is worth attempting to be able to use these pure intervals, even if it presents us with a series of problems that we need to solve using tempering. But if you can't hear a difference, which oftentimes people can't hear a difference between a piano in these two tunings, you will certainly be able to hear it with a sine wave. There's your Pythagorean, and there's your pure. Pythagorean. It is a noticeably stabler interval, and in order to tune it, we are going to have to modify our chain of fifths, right? In stacking 5 fifths, we come to Pythagoras major third, and if we detune this, we produce a wolf interval between the major third and the major sixth. The 3-limit Pythagorean major sixths is 27 over 16, the 27th harmonic, and the wolf interval is 40 over 27. Now, instead of changing the sixth and the whole tone from Pythagorean to 5-limit variations of them, such as 5 over 3 and 10 over 9, which would be to detune them by a 81 over 80 syntonic comma, instead of that, quarter comma mean tone is going to take one syntonic comma, divide it in 4, so into quarters, and it's going to distribute them among the fifths that are between the major third that we have now tuned perfectly to 5-limit and the tonic. It's a genius solution, and as long as you don't mind these puppy fifths, these barely wolf, wobbly little puppy intervals, you either get used to them or you write in a way that avoids them. And look at all these thirds you get. Some of them are a little sour. But even then, I think they are not unuseful musically. You just need to find the right context in which they add their own special flavor. And of course, we get the stack of major thirds, the augmented triad of 25, 20, 16, which is produced by stacking the quarter comma mean tone fifths, starting from the major third and stacking up 5 fifths to the minor sixth, 25 over 16. Now, if we play a bigger, more complex chord like a 13, we know that these intervals are going to be slightly drifting. That's the whole point of quarter comma mean tone, is that as we stack the fifths, they're getting smaller. We have a smaller ninth, and also that sixth or 13th. It's flatter than equal temperament or Pythagorean, but it's not all the way down to just intonation, 5 over 3. The major 7 is actually a bit flat of the 15 over 8 pure 5 limit, but it is a pure third sitting above the detuned fifth. And it gives us a unique major 7. Swirling kind of overtonal disturbance that's very light. Let's compare that with just intonation. You can actually hear that they're kind of squeezed together. The difference is subtle and will require some practice in order to hear. So as you mess around with this tuning, you start to figure out that certain keys have certain flavor to them, certain chords have a certain mood and atmosphere that is unique to quarter comma mean tone. Anyway, this is such a neat tuning. I hope people use it more often. I mean, today we have 53 equal temperament, which, solves the problem of quarter comma mean tone in a way by, instead of dividing the syntonic comma, it just provides all of your syntonic commas for you. So you can modulate around a circle of fifths that leads out and preserves all of these modulations in their just intonation and in their 3 limit and their 5 limit. And you don't have to use 53 equal divisions of the octave. You can use 53 just intonation divisions of the octave. And then you will have complete access to all of the Pythagorean and just 5 limit intervals. The Pythagorean are very alive and awake, and the just ones are softer and calmer. So Pythagoras and the Mean Tone Gang can hang out and be good. But if you're a lover of quarter comma mean tone and you can't get enough of those wolf puppy intervals, then you could make a mapping where you continuously stack major thirds and distribute the comma, and generate a quarter comma mean tone in which you could modulate much further and map to 53 keyboard mappings. So long live quarter comma mean tone, one of the raddest tunings out there. Thanks, everybody.